massive, enigmatic structures float across the vastness of space, a subject that has continuously left us with numerous unanswered inquiries. Yet, the time has finally arrived for a revolutionary shift. The James Webb Space Telescope reveals the inner workings of these towering enigmas, also known as black holes. Join us as we journey into the distant reaches of these cosmic mysteries to understand more about what lies within. If you wish to stay updated with the most recent discoveries from space and news, consider subscribing to our channel. Don't forget to like, share, and activate the notification bell to stay informed. It all began in 1916 when Albert Einstein introduced his general theory of relativity, which was the first to predict the existence of such entities. Though the term black hole was officially coined half a century later, many scientists had already accepted Einstein's theory, while others remained skeptical. In the late 1960s, when researchers were examining the X1 constellation, they made an astonishing observation. A peculiar, bright blue star was emitting X-rays, indicating it was not a typical star. This blue star was orbiting a gigantic, shadowy object. Further research revealed that the X-rays were not coming from the star itself, but were instead being drawn toward this enigmatic being. This discovery provided the first concrete evidence that black holes did exist. But this was only the beginning, and soon more astonishing revelations followed. The initial findings related to X1 triggered a series of subsequent discoveries that culminated in the conclusion that our Milky Way galaxy alone could be home to around 100 million black holes. However, due to their extreme difficulty in detection, we still lack a precise and accurate count. Current estimates suggest that the number could be in the millions, underscoring their significance as objects of research. Most physicists agree that a black hole is an object in which anything that falls into it is compressed to such an extreme extent that it forms a singularity. To simplify, they explain that if someone were to fall into a black hole, their body would stretch like spaghetti, slowly shattering into pieces before being reduced to this final, elongated form. This is one of the most unsettling aspects of black hole research, and is what drives humanity's intense desire to uncover their secrets. Despite this, the most well-known black hole is about 500 light-years from Earth. This still leaves us questioning whether or not black holes might devour our planet entirely. In 2021, scientists achieved a groundbreaking milestone by capturing the first-ever clear image of a black hole. Specifically, the black hole at the center of M87. Researchers spent several nights photographing this cosmic entity, with each successive image providing further evidence about its structure, ultimately revealing the presence of 3 primary layers. This discovery showed that black holes are not just empty voids but complex objects with distinct characteristics. To explore these layers further, we need to understand the first 2. The event horizon and the singularity. Let's dissect them. The event horizon marks the outer boundary of a black hole. Once an object crosses this threshold, it cannot escape and will either remain trapped or be drawn deeper into the black hole's core. The singularity, on the other hand, is the black hole's central point, where gravity is so immense and unyielding that not even light can break free. To escape, something would need to move faster than the speed of light, which, as we currently know, is impossible. It's crucial to recognize that gravity on Earth works differently from the gravity within a black hole. If Earth's gravity were similar, survival as we know it would be impossible. Once we pass the event horizon, we are confronted by the true mystery: the singularity. This is the point where the black hole's mass is concentrated, and everything is compressed into an infinitely small space, rendering the laws of physics as we understand them inoperable. Inside black holes, chaos reigns. It's important to note that no 2 black holes are identical. Each possesses its own gravitational pull and characteristics, meaning that studying one could give us insights that might not apply to another, like solving an endless puzzle. The issue, however, is that scientists can't study black holes the same way they study other celestial bodies like stars or planets. They can't simply observe the radiation emitted or the surrounding gas and dust. Sending a probe, such as Voyager, into a black hole's core is out of the question. Anything that ventures into this region would be destroyed before reaching the singularity. In essence, our only method of investigating these powerful cosmic objects is through indirect means, studying them in 2 dimensions, since getting close enough for direct observation is impossible. Right now, we've been unable to reach the singularity or uncover what truly lies beyond the event horizon. As we know, traveling faster than light is still beyond our capabilities. However, that doesn't mean that scientists haven't come up with some intriguing theories about what could be inside a black hole. Aside from the singularity itself, one of the most plausible hypotheses is that black holes might not be empty at all. Instead, there could be something more mysterious beyond the event horizon and the beginning of the singularity. Some theorists suggest that black holes could act like portals, offering a means of traveling between galaxies, and even different universes. Another fascinating theory proposes that black holes could be akin to glitches in the fabric of spacetime, similar to a matrix-like malfunction. If we ever develop technology capable of faster-than-light travel, we might be able to use black holes as gateways to other realms. But these theories remain speculative, and the field of science continues to search for more definitive answers. It's even possible that the singularity is not merely an empty void but instead a wormhole leading to another galaxy, offering a shortcut for interstellar travel, an idea once thought impossible. If this theory holds true, it could revolutionize our understanding of space and open up the potential for exploration beyond our own solar system. We might be able to harness these cosmic gateways and reach distant galaxies, broadening our perspectives in ways we've never imagined. On the flip side, there are scientists such as Tokyo-based Enryo and his group of researchers, who have proposed an alternative theory. They argue that black holes may not exist as we think but could instead be holograms. In this context, a hologram is not just a technological projection but could refer to any visual illusion or discrepancy in space. Given the vastness and peculiarities of the universe, anything is possible. It's important to remember that black holes continue to be a topic of intense debate among scientists. With each new discovery, our understanding of these cosmic giants evolves. Whether black holes allow for interstellar travel, act as gateways, are mere illusions, or are something entirely different, one thing remains certain: they are some of the most mysterious and fascinating objects in our universe. As technology continues to improve and our observational tools get more advanced, we may one day uncover the ultimate secrets of black holes. As we become more advanced, we might one day find ourselves closer to unraveling the deep secrets that these celestial anomalies hide. Some researchers even speculate that black holes could potentially be connected to other aspects of the cosmos in ways that we've never imagined before. Could they serve as conduits to parallel universes? Are they the remnants of ancient stars? Or are they part of a larger cosmic structure that we've yet to understand? These possibilities, though far-fetched to some, are not entirely outside the realm of scientific speculation. For now, our quest to understand black holes remains an ongoing challenge for physicists, astronomers, and cosmologists alike. Each discovery about black holes, whether it's the recognition of fresh ones or a breakthrough in theoretical models, provides another puzzle piece that may eventually help us decipher their true nature. But until we can find a way to directly study the singularity or travel through these potential cosmic doors, much of the mystery will remain unsolved. One thing that has become abundantly clear through years of black hole research is the role these objects play in the larger fabric of the universe. While they might seem distant and remote, black holes influence the behavior of galaxies, stars, and even spacetime itself. Their gravitational forces are so immense that they can distort the fabric of space, bending light and affecting the motion of nearby celestial objects. In fact, the very formation of galaxies may be correlated with the existence of black holes at their centers, making them crucial in shaping the universe as we know it. However, the science surrounding black holes doesn't just end with theoretical models or distant observations. Brand new developments in technology like the Event Horizon Telescope have brought us closer than ever to capturing images and understanding the complex processes occurring around black holes. These advancements allow us to gather data from the very edge of black holes, data that could help reveal their true nature. The Event Horizon Telescope's success in capturing the first-ever photograph of a black hole's shadow is just one example of how far we've come in exploring these enigmatic entities. Looking ahead, our hope is that we will keep pushing the boundaries of what is possible in astrophysical research. With upcoming missions, brand new telescopes, and novel technologies, we could one day get closer to not only unraveling the mystery of black holes but also understanding their potential role in the universe's grand design. Are these forces of nature merely cosmic curiosities, or are they the key to intergalactic travel? Only time and continued research will reveal the truth. As we continue to study and learn more about these massive cosmic structures, the possibilities remain endless. Will black holes eventually unlock the door to distant galaxies? Will we ever find a way to escape their gravitational pull? Only time will reveal what lies beyond the scope of current observation. And perhaps someday, we'll be able to answer questions that have perplexed humanity for centuries. As our understanding of black holes deepens, we must acknowledge that we're still only scratching the surface of their complexities. While current theories and models have provided substantial insight, they only represent a glimpse into the vast unknown. The nature of black holes challenges many of the fundamental principles of physics, forcing scientists to confront ideas that once seemed impossible. In fact, some of the most profound discoveries about black holes may not come from what we know, but from the gaps in our understanding that continue to inspire new avenues of research. The more we study black holes, the more we realize that these entities could hold the key to unlocking some of the deepest mysteries of the universe. From their role in galaxy formation to their potential connection to quantum mechanics, black holes are not just isolated anomalies. They are important players in the cosmic narrative. For example, the energy emitted by the region around a black hole, known as the accretion disk, has been found to influence the behavior of surrounding stars and gas clouds. This shows that black holes can impact their environments in ways we're only beginning to understand. Moreover, recent studies suggest that black holes might also play a role in the future of space exploration. If, as some theories suggest, black holes are not simply destructive forces but rather bridges between different parts of the universe, they could one day provide the means for faster-than-light travel. Imagine a future where humanity is able to explore distant galaxies by passing through black holes, bypassing the immense distances that separate us from other star systems. While this idea is still speculative, it's an exciting prospect that has captured the imagination of both scientists and science fiction enthusiasts alike. The idea of traveling through a black hole also ties into the notion of time itself. If black holes indeed act as portals, as some theorists propose, this could suggest that they might provide shortcuts through time as well as space. This concept challenges everything we think we know about the nature of time, potentially offering a way to travel not just across the cosmos but perhaps even backward or forward in time. Such theories, though fascinating, are still far from being proven, but they do suggest that black holes could have even more significance than we previously thought. Meanwhile, the more grounded approach to studying black holes continues through advancements in technology and observation. Instruments like the Laser Interferometer Gravitational Wave Observatory (LIGO) have already allowed scientists to detect gravitational waves, ripples in spacetime caused by events like black hole mergers. These discoveries are changing our understanding of the universe, providing us with a new way to observe and study these enigmatic objects. It's likely that, in the coming decades, new technologies will continue to push the limits of what we can observe, revealing even more about the behavior and characteristics of black holes. In addition, space telescopes like the James Webb Space Telescope and the Hubble Space Telescope are providing us with clearer and more detailed images of black holes and their surrounding regions. These observations allow scientists to study the effects of black holes on nearby stars, gas clouds, and even entire galaxies. By examining how these powerful objects interact with their environments, researchers can gain valuable insights into how spacetime behaves under extreme conditions. With every new observation, we edge closer to comprehending the true nature of black holes and the role they play in the broader universe.